Okay, welcome friends. After the discussion of the different topics of this mechanics and the mechanics of solids, now let us discuss a problems based on the previously discussed topics, that is the torsion, twisting couple, torsion of the circular shafts or the cylinders. So one problem I have today to discuss. So as the problem is written over there on the board, it is simply a hollow steel shaft transmits 200 kilowatt power at 150 round per minute. The angle of the twist in the length of 5 meter is 4 degree. Find the inner and the outer diameter of the shaft. If the permissible shear strain is 60 megapascal and the modulus of the rigidity is 80 gigapascal. So to discuss this problem, so first we need to understand what we want to find out. So for that, it is given here that we need to find the inner and the outer diameter of the shaft. So let us draw the inner and the outer diameter. If this is the hollow circular shaft, we may consider it as a circular shaft, although it is not exactly circular. So but we are considering that this is the inner diameter. If we will represent this inner diameter by d1, and the outer diameter of this, maybe if this is our center point, so this is d2. So this we need to find out. Okay, so what we have considered, that we have considered that the diameter of the hollow shaft for inner, let us consider the inner diameter is d1 and outer diameter is d2. So what the values given in the question, so what is given, that also we will need to write here. So given is it's the power is given P, that is 200 kilowatt. Either we can say it's 200 into 1000 watt. Okay, and N is given, the number N is what, it is the uh, number it is given in the question, it is 150 round per minute. So how much value of the N is, that is 150 rpm. Also in our question, when we are just discussing for further, we will I'll tell you. Okay, so now what is the angle of twist, that is given here theta, that is 4 degree. If we will convert this in the radian, you know about the conversion of the radian and the degree. 180 degree is equals pi radian, so we will convert it. So I'm just putting the value directly. I've solved these values, so it's 0.0698 radian. Okay, so L length is given 5 meter, and the value of this, so P, that is given 60 megapascal. We can say it's 60 into 10 to the power 6 pascal. And similarly the value of this rigidity of modulus, or the modulus of rigidity, that can be, it is 80 megapascal. It is given, it's not 80 megapascal, it's gigapascal in the question. It's gigapascal, so we can write it here as 80 into 10 to the power 9 pascal. So in the pascal we have converted all these values. So what is the formula that is used in the previous videos? We have derived the formula. For that, So let me write this formula again. So what it will be, it is simply, tau upon r is equals t by j and theta over l. This we have derived in our previous video. So we need to put the values here. In some reference books, this n is replaced by g, and it understand the same value, same thing, but the denotation is different. Okay, here we have denoted this by n, and in some reference books it is denoted by the g. So we will consider it as n here. So what is the power p? We can find out it, as we know it's 2 pi n t. So t, we can find out t is what it is. Now by this formula it is p over these values will be like 2 pi n. Okay, so n is what? N is the power at it is the 150 round per minute, and is the 150 round per minute, the number of the rounds per minute. So here all the values will be, if we are following the SI system, then we need to convert this in the rounds per second in place of round per minute. So here we have put this value, so 150 round per minute. In place of that we can write it as, it is 150 divided by 60 round per second. Okay, it can be written as like this. So if we will put the value here, all the values we have, p we have this particular value, pi we know, n is this value we will put. So we can put it here and we will find out the value of this t. So that will be, p is here 200 into 1000. Okay, and divided by this 2 into 3.14, and into n is what? Now it's 150, and divided by 60, so 60 I'll write here. So finally, on solving, I have the solution of this. On solving, almost you will get the value. By calc you can solve this problem, solve this calculation. So it will be 12732.39 Newton meter. So this will be the value of this t. So for the hollow shaft, let me erase these values to have some space on this whiteboard. So let me put these values. You need to remember, either in some previous slide you can note down these values, and let us put, we know that for the hollow shaft, j is equals, it's pi by 32 d24 minus d14. Okay, and from some previous equation, here from this equation we can say this r can be calculated in terms of this. So we can say what is it? It is tau by r is equals n theta upon l. So from this we can say it's r is equals tau l upon n theta. So r is what? R is d by 2, that is r. Okay, so if we are considering for d2, so it is d2 by 2, so it is r2. If it is d1, then it is d1 by 2 is r1. So putting the value here, it may be d2 by 2 is equals tau l upon n theta. So we have all the values here. So by this we can say d2 is equals to tau l upon n theta. Substituting these all the values in this formula, so now we have all these values to put in this formula. So here is So it's d2 is equals 2 into the value of tau, that is 16 to 10 to the power 6, into L we have 5 meter, and divided by N we have it's 80 gigapascal, so 80 into 10 to the power 9 into theta. In the radian we have converted it, so it is 0.0698. so on solving this you will get the result, so that will be 0.10743 meter. So this is your d2. So the value of the d2 we have find out right like this. So and we know that t over j, that is equals to n theta upon L. So j is equals t L upon n theta. Okay, so j we can put the value of j, previously I told you about the formula. So we can say it's pi over 32 d2 4 minus d1 4, that is equals to tl upon n theta. So almost all the values we have. So what will be the formula now? It is d2 4 minus d1 4, that is equals to 32 over pi tl upon n theta. So like this we can put all the values here in this equation. So it's d2 4 minus d1 4, that is equals to 32 upon 3.14 into its t we have calculated right now. So it's 1273.395 into 5, the value of L, and then the value of N, that is 18 to 10 to the power 9 into the value of this angle, said that is 0.069813. Okay, so by putting these values and on solving this we can have the value. So finally we will get the solution of this term. It is 1.161 into 10 to the power minus 4. So this is the value of d2 is d to the power 4 minus d1 to the power 4. So if we know the value of d2, so d1 can also be calculated by using this term. So let me erase this from here. So we will put the values. So in this equation we will have d1 4 is equals d2 4 minus 1.161 into 10 to the power minus 4. Okay, so we have the value of this, so we will put the value of d2. It's 0.10743 to the power 4 minus 1.161 into 10 to the power minus 4. So on solving this you will get the result of d1, and that will be 0.0643 meter almost, I think so. Okay, you may tally or verify all the values. So by this we can find out the diameter, which we need to explain diameter for the inner and the outer circles of that hollow cylindrical shaft. Okay, so thanks for watching. So for any problems or any queries, you may subscribe the channel, and you are free to give your suggestions also on my YouTube channel. Thanks for listening.